Hi guys and welcome back. So today here we have an HP laptop for repair. So I received only the motherboard. So this is a no power case, so it doesn't turn on. And also this motherboard has been checked by two technicians previously and they couldn't fix it. So it just came to our shop. So let us see whether we can fix this for the customer. Okay, so before starting our diagnosis, so as this motherboard has been already checked by the previous technician, so we should check for if there is any component missing on this motherboard, and then only we can start our diagnosis. So you can easily spot here, so this component is missing. I don't know what does this doing here. We need to check that later. So this IC is missing, and let me check other sections as well. So this is a charger IC, I guess, near to the battery connector. I don't know. Okay. And on this side looks clean. Yes, so here also we have some flux residue, so they have worked on this side here. Okay. So it looks like they have worked on this side as well. So this is the clock generator of this motherboard. So that looks fine. Okay. Yes, so that's it on this side. So turning out on the other side. Yes, so we have the V in MOSFETs. Okay, the first and second MOSFETs. Yes, so here also we have some flux residue. So this is the GPU sections as well. So I think they have tried to disconnect the GPU and try to turn on the motherboard. I don't know. Okay. Okay, so here also we have some residues, flux residue, and these two capacitors are missing. Okay. And they have worked on the BIOS chip as well. You can see the flux residue. Alright, so they have touched some of the components on this motherboard here. So anyhow, we will try our best to fix this. I'm not sure whether I can fix this one. Anyhow, let us try. Okay. So before injecting the power, I will just try to check the diode value of all the inductors here. I will check both upper and lower MOSFET because we don't know actually the actual condition of this motherboard here. So before connecting the adapter, first I will confirm whether all of the inductors are proper in their value. Okay. Alright, so let me check each inductors. Yes, so I can find a command point, the main power rail on this electrolytic capacitor, the ash color electrolytic capacitor on the anode side. Yes, okay. And checking each inductors. 530, okay. Yes. 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 No reading. Yes. Okay. 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 Okay, so all of the upper MOSFETs are fine. So let me check the ground resistance with regard to its load. Okay. CPU core inductors, so they are very low in resistance, so that is fine. Yeah, this also fine. Yes. Yes. Okay, so everything looks perfect. So there's no short in this motherboard through the inductor. So that is fine, and it is safe to inject power now. Okay, so look at the ampere reading on the DC power supply. Now I'm going to connect the adapter, and yes, so it is drawing around 13 milliamps, and we don't have the light on the DC jack. So usually EC chip will turn on this LED here as white when the adapter is plugged in, and the EC chip will turn on with regard to a signal that is sent by the charger IC to the EC chip when the adapter is plugged in. So charger IC is the only IC that detects when the adapter is plugged in, and it will send the adapter input signal to the EC chip. Then the EC chip will turn on this light as white. And when you connect the battery, if the charging is enabled, then it will turn this as orange. So that's what controlled by the EC chip, and this light is being controlled by the EC chip. So if you don't have a light on the DC jack, so it can be a problem with the charger IC or with the EC chip or with both. So we need to find that. So I guess the charger IC would be the problem. So it may not send the AC in signal to the EC chip, then it will not turn on the light. Okay, anyhow, we will see. So now let me see whether we have a main power rail in this motherboard here. Okay, I'll just see the LDO voltage in this motherboard here. So we can use the battery connector. And we don't have anything. Yes. Okay, so the LDO voltage is not present on this motherboard. So that's why we are not getting a white light on this DC jack here, because the EC chip hasn't turned on. Okay. Right. So let me see whether we have the main power rail in this motherboard. Okay. So we can check on this capacitor here on the positive side. And yes, so we don't have the main power rail. So main power rail is missing on this motherboard. So 19 volt is not there. And if I check on the first MOSFET, and we have 19.63 volt. So the DC jack is proper, and it is injecting 19 volt on the first MOSFET. All right. So now we need to focus on the charger IC and why it is not switching the 19 volt into the motherboard. So let me see whether if there's any short on the main power rail itself. I'm sure there's no short because the diode reading was proper. Yes, we don't have any short, so 500 is fine. Okay. Yes, so this must be the charger IC. Let me check it. It looks like. Okay, so this is the charger IC here, so which is written as BQ7. So it's not visible, I think, but I can see. So this is a product of Texas Instruments, and now we need to check certain requirements surrounding this charger IC for it to switch the 19 volt into the motherboard. So basically on pin number 20 we should find 19.5 volt approximately the adapter voltage, and it is straightly connected to this resistor here, which is a 22 ohm resistor, and the value should be approximately around this value. Okay, and on pin number 16 that is straightly connected to this capacitor here, and we should find generally 6 volt or 5 volt on this capacitor here. And on pin number 6 on this point we should have a voltage within 2.4 to 3.15. So typically we will find 2.6 volt on pin number 6. Yeah. So this is the adapter setting voltage input. So if you have a voltage which is less than 2.4, then the charger IC will understand that the adapter that is connected to the motherboard is having an under voltage. So the voltage is not enough for the motherboard, and it will cut down the voltage into the motherboard. And also if you have a voltage greater than 3.15, then the charger IC will sense that the adapter is having an over voltage, so which means it is too much for the laptop, and then it will cut down the voltage into the motherboard. And if you have the voltage within this range only, then the charger IC will sense that the adapter that is connected to the board is valid, and it will turn on the voltage into the main power rail. So we should have approximately 2.6 volt on this pin here, and if charger IC has sensed it properly, it will send 3.3 volt on pin number 5 as AC OK to inform the EC chip to turn on the light and also to turn on the adapter light, and then it will turn on all the standby regulators. Okay, so this is the sequence of turning on the standby supply. All right, so let us check one by one. Okay, so now let me check the voltage on the supply of the charger IC here, supply pin of the charger IC, input before the resistor. Wait a minute, I'll just connect the adapter. Okay, yes, we have 19.63 volt, that is fine. After the resistor we have 19.33 volt. Okay, so this is quite lesser, so let me check the resistance value of that resistor. Yes, 22 ohms, approximately correct. Okay, let me check the resistance value for the charger IC. Maybe the charger IC may have gone shorted, then the voltage will drop. No, the reading is proper, 2.9. That drop value is actually a good resistance value for the charger IC. Okay, now let me check on the pin number 16, and wait a minute, let me connect the adapter. Okay, yes, we should have 5 volt. Wait a minute, 12 volt. What is that? Am I checking the right pin? Yes, so 20 is there, 15 is below part. Yeah, that is 16th, and we should have a 6 volt on this point, but we are having 12 volt, so this is incorrect actually. So this is 12 volt. So checking on the pin number 6. So on pin number 6, and we don't have any voltage. Yes, 0.6 volt, so we should have 2.6 volt on this pin here. On pin number 5, here also we don't have anything. Yes, so okay, I think there's a problem with the charger IC. So we are having 12 volt on the VDDP or RGN output, so that should be around 6 volt, but we are having 12 volt. Okay, I'll just try to replace the charger IC. So if you replace the charger IC, I think we will get the main power rail and the board should be working fine, I think. Okay, let's see. Okay, so now I have replaced the charger IC, so let me connect the adapter. Yes, so it is drawing around 8 milliamps, so somewhat lesser than before. So still we don't have the adapter light on the charger DC jack. Okay, so let me check again with the charger IC's requirements. On pin number 20, do we have a voltage on this resistor here? Yes, so now we have 19.62, so the correct voltage on both sides. So earlier we had 19.3 or something, now we are having the appropriate correct value. And on pin number 16 on this resistor here, yes, so you can see now we are having 6 volts. So this is the approximate value, which is the RGN, which should be 6 volt. Okay, and on pin number 6, yes, so we have 2.7 volt. So approximately I told you we should have 2.6 volt, but we are having 2.7 volt, so that is fine. So which is within the range, so that should be within 2.4 to 3.15, and we are having 2.7, so that is fine. And on pin number 5, yes, so we are having 3.3 volt also. This is the AC OK signal to the EC chip to turn on the adapter light and also to turn on the standby voltages. Okay, but still we don't have a light on the DC jack. Okay, so let me check whether we have the LDO voltages in this motherboard to check or confirm whether the standby IC is working properly. So 2.7, so I'll use the battery connector. Yes, so we have 3.4 volts. Yes, so the LDO voltage is present. So the EC chip should be working fine now because it should receive its power. Let me check whether we have the 5 volt and 3 volt. Yes. No, we don't have any voltage there. So only the LDO voltage is present now in this motherboard. Okay, no any other voltages. So this is the battery coil, so we will have a voltage, so that is fine. No any other voltage. So now we need to check the requirements of the SIO, which is the EC chip, in order to turn on the adapter light and also to turn on the standby voltages. So as we don't have the adapter light on the DC jack, I can confirm. So some problem is there with the EC chip, so that's why it is not turning on the adapter light. So maybe EC chip may not have some important signals like EC reset. So if the EC reset is low, then EC chip will not start its internal function. So in that case also we will not have the adapter voltage on this motherboard here. So now I need a schematics in order to find where we should check the requirements for the EC chip. Okay, so I'll just try to find the schematics for this one. So this is the part number here. Okay, so I'll just try to find a schematic so that we can start our diagnosis from the EC chip and check its basic requirements for it to turn on the adapter light and also to turn on the standby voltages. Okay. Alright, so this is the schematics of this motherboard, and also we have the board view as well, so this will be easy for us to find the components quickly for checking purpose. And if you look at the block diagram, so here we have the Intel Shark Bay, which is a 6th gen processor. So this is an SoC technology, so PCH and CPUs integrated together. And on this side here we have the GPU for this motherboard, which is the AMD, and which is connected through the PCI Express line. And you can see another line going to the LVDS and EDP and HDMI ports for providing the display output from the integrated graphics, which is from the CPU. So this is a graphics conversion possible motherboard. So if you look at the graphics, dedicated graphics here, if the dedicated graphics fails, if the GPU fails, then you can disable it and you can get the integrated graphics from the CPU itself. So that is the meaning of this block diagram. So if you look at some other block diagram, you will find only the lineups on this side from the GPU only, not from the CPU. So there will be only LVDS, EDP and HDMI from the dedicated graphics, but not from the integrated graphics. So on that case, you can't convert that graphics into integrated graphics, so you can use only the dedicated graphics. For example, if you look at this schematics here, so this one is having the CPU and PCH as separate, and you can see on the left side, so dedicated graphics only takes the video signals to the CRT and LCD, but PCH doesn't handle any display output sections. Okay, so and if you look at on the communication between the CPU and PCH, they have only the direct media interface. So if the PCH delivers display signals to PCH, then you will see another arrow on this side as FDI, but you don't have any display communication from the CPU to PCH. So in this case, if the GPU fails, you have only option to replace another GPU to get a display on the LVDS and CRT connectors. So to confirm this, I'll just go to the LVDS sections in this motherboard, in the schematics. Go to power section. Yes, so this is the power for the PCH, and we have different power inputs. And if you look at the LVDS sections, they have just grounded these pads. So this means they have disabled the LVDS output, I mean display output from the PCH, and they are using only the dedicated GPU, dedicated graphics from the GPU. So you can convert this if the GPU fails. Okay. Okay, so moving down to SoC, I mean the SIO, the EC chip on this motherboard. Let me search AVCC. So this will take to the SIO. Yes. So first we need to check whether we have the EC reset signal on pin number 37. So this is a very crucial signal that should be there always, that should be there for the EC chip to start its internal function. And then we should find the RSM reset signal also, that is on pin number 100 usually, yeah, on pin number 95 on this SIO. So we need to find the RSM reset signal on pin number 95. Okay, and then we need to find the AC in signal, which is a derivative of AC OK signal. Yes, so this one is here. So they have mentioned as it's an output signal. So let me check that. No, actually it is an input signal from the, yes, so it's an input signal from the charger IC here. So this will tell the EC chip that the adapter has been plugged in. Okay, and then only the EC chip will release all the standby enabling signals. And also it is going to this switch here. So this is a controller IC, so which is, you can see LAN power is there, main on, sus on. So these signals will be fed into this controller IC, and then the controller IC will control all of the load switches here, so load MOSFETs. And also this IC also will send a power good signal, and they have not connected to the circuit here, so we can just leave it as it is. And if you go to the charger IC, so the charger IC is only sending the signals as an output to the EC chip. So we need to find 3.3 volt on pin number 76 in order to confirm that the adapter has been detected. Then only the EC chip will send the S5 on signal. S5 on signal, where is that? S5 on OEC on signal. We need to find that. Yes, it's here. So S5 on signal will be sent once it receives the AC in signal on pin number 76. So this is on pin number 101. Okay, so we can first check these points. Okay, so first we can check the EC reset signal, which is on pin number 37. So now let me connect the adapter. Look at the ampere reading. Yes, 8 milliamps. Now it is drawing 57 milliamps. So something is happening on this motherboard right now. Okay, let me check first. The EC reset signal 33, 34, 35, 36, 37. Yes. And we have 3.3 volt, so that is fine. So before we had no improvement on the ampere reading, just it was stuck around 8 milliamps. Now we are reading around 57 milliamps. So this is the RSM reset signal on pin number 95, and we are having 0 volt. So we should have 3.3 volt for the board to turn on. So if the RSM reset is 0 volt, the board will not turn on, because the RSM reset is the calling bell for the PCH to wake up from the deep sleep. So if the RSM reset is 0, then the PCH will not wake up from the deep sleep to release the S4 and S3 signal to high. Okay, so let me check whether we have the AC in signal, that is on pin number 76. Pin number 76 of 65, 70, 1, 2, 3, 4, 5, 6. Yes, on this pin here. Yes, so we have approximately 3 volts. So AC in signal is okay. Now let me check on pin number 101 whether we are getting S5 on signal. So this is 100 and this is 101. Yes, we are having around 1 volt or something. Yes, so let me check whether we have the coil voltages. No, we don't have. And now you can see the ampere reading went back to 8 milliamps. So I'll just try to disconnect and connect again. Yeah, 8 milliamps. Yes, now it is stuck at 8 milliamps. So earlier we had 57 milliamps, then it went back to 8 milliamps. Okay. So this is the S5 on signal. And we are having, okay, when I touch this pin, I'm getting 57 milliamps on this pin here. Okay. So actually we should have 3.3 volt on this pin in order to get the coil voltages. Okay. So let me check the coil voltage. Yes, now we are getting 3.3 volt and 5 volt on this pin. So that is fine. So do we have a dry soldering on this pin here? I don't know. So why we are having just 1.0 volt on this pin? We should have around 3.3 volt, but we are having only 1 volt. So 2 volt, okay. Fine. So now let me just try to press the power button and see whether we are getting any change. Okay. So once I press the power button, yeah, it went back to 8 milliamps. Okay. So still we are having a problem on this motherboard here, which is I'm related to the EC chip. Still we are not getting the adapter light. So you can check the voltages now at 0.9 volt, 1 volt, and we are getting the 5 volt and 3 volt coil voltages. So that's why we are reading around 550 milliamps. So the voltage from the probe is going into the S5 on signal. So the standby IC is detecting that the enable signal is sent. So that's why it is releasing the 5 volt and 3 volt coil voltage. So once I remove the probe, the voltage will be missing on that point, and then it will go back to 8 milliamps. So if I press the power button, it should go back to 8 milliamps. So but this time it is not going to 8 milliamps. So okay, that is fine. So what can we do now? So we are not getting the RSM reset signal. So I will just probe on the pin number 95 and try to trigger the power button and see whether we are getting 3.3 volt on that pin. Okay. Pressing the power button. Yes. No voltage. So we don't have voltage on the RSM reset signal. Okay, so we have 10 kilo ohms. So this is a pull-up, internal pull-up. So we are having only 10 kilo ohms. Okay, no problem. So when you look at the EC chip here, so the model number is KB9010. It's not visible, I think. Yes, KB9010QF C4. So basically this EC chip has an inbuilt, it has an firmware inside this chip. So we need to program this EC chip in order to work. So I think the firmware inside this EC chip may have gone corrupted. So that's why it is not sending the RSM reset, and also the adapter light is not glowing. So these two important points can tell us that there's a problem with the EC chip here, with the firmware. Okay, so when you look at this EC chip, so this is ENA brand, and there are different kinds of EC chips like Norton, then SMSE, IT, MEC, and there are different kinds of EC chips. So when you look at this ENE EC chip, so you can see its part number starting like KB9010. So this is a starting series that has the integrated BIOS inside this EC chip. So if you want to program this EC chip, you can directly program into this EC chip rather than external BIOS chip here. So when you look at the part number like KB930, so those EC chips of the ENE does not have the integrated BIOS chip. So it has a dedicated BIOS chip outside the EC chip, and then it will communicate to the BIOS chip in order to get its firmware in order to function. So on that case, if you have a corrupted BIOS or firmware of the EC chip, we can directly flash the BIOS chip on the outside. But when you look at this model here, after this model 9010 series and 9020 series, after this model, we need to program the EC chip itself. So in order to program this EC chip, we need to have programmers like SVOD, init programmers, and veteran and things like that. However, these programmers are very expensive, and also investing money on these programmers will not give us more benefit, because when you receive a motherboard for repair, so having an SIO damaged or SIO shorted or like SIO firmware corrupted is very rare on most cases. So investing on these kinds of programmers are actually not much beneficial for us. So actually I don't have those programmers, and also I don't want to invest money right now on those things. However, today I'm going to show you how to program this EC chip using a USB programmer, so which is a budget programmer. You can get it easily anywhere on AliExpress or eBay. So I'm going to use that USB programmer, which is well known as CH341A. So I'm going to use that programmer to program this EC chip. So actually we can't directly program this EC chip using that programmer. We need to solder some of the pins of the EC chip, and then we can program this EC chip here. So I'll just show you how to program this EC chip using the USB programmer and see whether we are getting adapter light and also the S5 signal released by the EC chip. Okay, so this is the programmer that I'm going to use to program this EC chip here. So you can see it's part number CH341. So if you are going to use this programmer, you need to do a small modulation when you buy it. So when you look at this programming chip here, so it receives 5 volt as an input supply through the 5 volt USB line, and it will inject the 5 volt into the BIOS chip in order to program it. But actually BIOS chip works on 3.3 volt or 1.8 volt. However, here we have a regulator which is 3.3 volt regulator. When you supply 5 volt, it will generate 3.3 volt. So we can just isolate one of its pin from its pad and lift it above, and then we can connect from here to here. So the last pin on this side, on this corner, you need to lift one of this pin above, and then you can solder a wire to this regulator here. Okay, then you can use it. So on this side, if you turn it on back side, so here we have the pins, so which is CLK means clock, CS means chip select, MOSI means master out slave in, and this is master in slave out, and also here we have the ground, and we have 3.3 volt as well. So if you are not going to power the motherboard, you need to use all of these pins except this 5 volt. But if you are powering the motherboard externally using the adapter, then you can avoid injecting 3.3 volt. However, you need to provide the ground to make it as a common ground for the USB programmer and the motherboard as well. So now we need to use around 5 pins from this programmer in order to program this EC chip here. Okay, So we will just solder all the pins from here to the keyboard connector and see whether we can program the EC chip using this programmer. Okay, this is the data sheet of ENE 9012 EC chip. So if we go to page number 25, we can find the pinouts that we can be used to reach its internal firmware or the BIOS chip. So yes, so this is the terminal. So through pin number 59, pin number 50, 61 and 62, these are the pins, 4 pins that can be used to communicate the BIOS chip inside this EC chip. Okay, so rather than just soldering the wires directly on the EC chip, we can communicate the EC chip using the keyboard connector. So we can use KSI4, KSI5, KSI6 and KSI7 pins, and then we can solder those wires into USB programmer into these respective pins on the programmer, and then we can program it. And also additionally we need to solder KSO3, so which is KSO3 on the keyboard connector. We need to solder this pin to ground in order to enable the BIOS read function through the keyboard connector. So if you don't ground these pins, this pin KSO3 to ground, then we can't read the BIOS using the keyboard connector through these pins. So we need to ground it, and on that case we can read the BIOS. Okay, so now let's move on to USB programmer and connect these pins to the keyboard connector and to the programmer. Then we will just try to read it. Okay, and also these are the pins that go straightly to the keyboard connector. So you can see KSI is on this side and KSO is on this side. So we need to focus only on KSI. So KSI4, KSI6, I5, I6 and I7, and also KSO3. So we need to connect these pins to the programmer, and also we need to ground this KSO3, which pin number 42, to ground. So I'm not going to straightly do this on the EC chip. I can use the keyboard connector and use the keyboard connector to connect these wires. Okay, so now I have soldered all the wires onto this programmer, including the ground pin, and also I have soldered onto the keyboard connector here, right on this side. So these 4 pins are for the chip select pin and the data in, data output and the clock pin. And on pin number 15 here, so this is for the KSO3. So I have straightly connected to the ground of the capacitor, and I have connected this pin straight to the ground of the USB programmer. So now we can connect this USB programmer to the computer to program this EC chip. Okay, so now let me open the USB programmer. So I'm using Neo programmer, which is best for this programmer here. Okay, so when you are programming the EC chip of ENE, so you can only program the ENE EC chip using this programmer. So if you select detect, it will say as the IC not responding. So you have to manually select it. So you go to search, then type KB90. So you can program all of these using this programmer. So we don't have KB9010, so we can select this one here, which is KB90 and X on this side, so you can put anything on that side. So we can select KB9010 and select read here. So this will read all the information in the BIOS chip inside the EC chip. Okay, so let's wait until it reads. First we will take a backup of this one and we will copy it and save it. Okay, so I'll just save it .bin. Okay, yes, so now we can erase this IC. Just click erase and this will erase the program inside the BIOS chip. Okay, so now we need to program with the correct BIOS here. Yes, it's here, so you can select only the EC, which is 131, so which is 128 kilobyte. Go and paste it here. Yes, so let's program it. Select program. Yes. So let's see whether we are getting the adapter light this time after programming the EC chip. So if we still don't have the adapter light, then we need to replace the EC chip, or else we need to resolder the EC chip. Okay, first we will resolder the EC chip and check, and then we can replace another EC chip. Okay, now it has programmed, so now let's move on to checking the motherboard by connecting the adapter. Okay, so I'm not going to remove these jumpers right now, so I need to check whether the program is fine. So I'll just remove KS03 to ground and left it open so that the BIOS chip can be read by the EC chip inside it. Okay, so the firmware can be read by the EC chip. So I will just make the KS03 open line from ground so that EC chip can read it. Okay, connecting the adapter. Yes, we are reading 10. Yes, 12 million. Yes, we got the adapter light. Wow, amazing. So the ampere reading is around 2 million right now, and the adapter light is glowing. So now the BIOS has been correctly programmed for the EC chip and the firmware is okay. So that's why we are getting white light on the adapter. Okay, so now we can disconnect these jumper wires. So everything is working fine. So the problem is with the EC chip's BIOS firmware. Connecting the adapter again. Yes, we have the white light. So pressing the power button. Yes, the board has turned on. We are getting around 600 milliamps and the fan is spinning. So I think everything is okay. Yes. So let me connect a mouse. So let's see whether we are getting a display. Okay, let's wait for some time. Yes, we got the display. So we have a small adjustment with the mouse here. Yes, so we got the display and everything is working fine. Okay, so now let me check the RSM reset signal after programming the EC chip, whether we have any voltage there before and after pressing the power button. I'll just check. Usually if the BIOS firmware or the firmware of the EC chip is corrupted, you will not get the RSM reset signal. So on that case also we will understand that the BIOS chip is having a problem inside the EC chip. Okay, so now we don't have any voltage. Now let me press the power button, and yes, so we have a voltage. Okay, so I'll show you that again. The multimeter was hidden. Okay, now turned off the board and we are reading 0 volt, pressing the power button, and yes, we got 3.3 volt and everything is working fine. So if the RSM reset is 0, then we can confirm that SAO requirements are not met. Some of the SAO requirements are missing. So we need to find that and fix it. So in this motherboard, the problem was only with the firmware of the EC chip. So now we have programmed it. So everything is working fine. And also on this side, so we saw this chip was missing, and this is for display converter IC. So this motherboard has EDP technology, so and this port is LVDS technology. So we can't just connect directly the EDP signal directly to the LVDS connector. So that's purpose. For that purpose, so they are using a converter IC to convert the EDP signals to LVDS line. So I need to replace this IC, then I can give it to the customer. So I don't have this IC right now, so I have to order it, and then I'll replace it and give it to the customer. Okay, right. So thanks for watching, guys, and see you later in a new video.